Hi, welcome to my YouTube channel. I am Sarah Midelantar, and in this video we will discuss about scheduling algorithm. First thing to discuss is about first come first serve scheduling algorithm, and followed by the shortest job first scheduling algorithm. First come first serve. First come first serve scheduling algorithm, as the name suggests, the process which arrive first get executed first. Or we can say that the process which required the CPU first gets the CPU allocated first. Or in the other words, first in first out queue data structure, where the data elements which is added to the first queue is the one who leaves the first queue. As you can see, in this table, it has the process number, arrival time, and the burst time. Through this table, we can calculate the average waiting time. In this table, we can calculate the average waiting time, considering that the processes P1, P2, P3, P4 in these tables arrives the execution in the same order, with the arrival time of 0 and the given burst time. Let's find the average waiting time using the first come first served scheduling algorithm. The formula for average waiting time is the finishing time minus average time minus burst time. Considering that the P1 has the finishing time of 15, the arrival time of 0, and the burst time of 15 is equals to 0. 15 minus 0 minus 15 equals 0. Followed by process 2 or P2, which has finishing time at 18, arrival time at 1, burst time at 3. 18 minus 1 minus 3 is equals to 14. The P3 with a finishing time of 22, arrival time of 2, and burst time of 4 is equals to 16. 22 minus 2 minus 4 is equals to 16. And P4, and for the P4 with a finishing time of 30 minus 3 minus 8 is equals to 19. In calculating the average waiting time, adding all the total value of each processes, divide by 4 is the total answer. The total answer will be considered as the average waiting time. 25 will be considered as the average waiting time. Given For the above given processes, first P1 will be provided the CPU resources. Hence, waiting time for P1 will be 0. P1 requires a 15 for completion, hence waiting for the P2 will be 18. 15 plus 3 is equals to 18. It's considered at P2. Similarly, waiting for the process 3 will be executed time of P1 plus executing time for P2, which will be added, and the result will be the process 3. 15 plus 3, 18 plus 4, 22. For the process P4, it will be the sum of the execution time of P1, P2, and P3. So the result will be 30. 15 plus 3 plus 4 plus 8 is equals to 30. This chart is perfectly represent the waiting time for each process. Shortest job first. Shortest job first is the scheduling algorithm in which the process with the smallest execution time is selected for the execution next. It can be either preemptive or non-preemptive, owing to its simple nature. Shortest job fair is considered optimal. It has also reduced the average waiting time for each other processes awaiting execution. Shortest job first is also known as the shortest job next and the shortest processes next. This table shows the non-preemptive shortest job first. So, considering below the process available in ready queue for execution, with the arrival time at 0 for all. So we considered below the process available in ready queue for execution with the arrival time of 0 for all ungiven bursts. So as you can see, we only have only two columns, the process number and the burst time. We don't need to have a column for arrival time because we considered it a 0, as what I've said earlier. So in shortest job first scheduling, the shortest processes is executed first. P2 is our shortest process. It only have a burst time of 3, followed by P3, which has a 4 burst time, and P4 has 8, followed by 1 has the highest process burst time. So, the average waiting time for shortest job first is just the same for first come first served scheduling, but the difference is we consider the shortest process executed first. So since our shortest process is P2, so P2 has a finishing time of 3 and the arrival time of 0. As what I've said, all arrival time is considered as 0. So let's continue. Minus so 0 minus 3 is burst time is equals to 0, followed by the 3 followed by the process 3, which has the finishing time of 7, arrival time of 0, and burst time of 4 is equals to 3, followed by the process 4 is equals to 15, finishing time, arrival 0, burst time is 8 is equals to 7, and followed by the P1 lastly. Finishing time is 30, arrival time is 0, and the burst time is 15. So it's by calculating the average waiting time, the total average of all the processes value is divided into 4. And the result will be, you can see we scheduled the same set of processes using the first come first serve algorithm in the previous slides and get the average waiting time of 12.25, as whereas with shortest job first, the average is 6.25. So that's all, and thank you. Thank you for watching my videos, guys, and please do subscribe for more videos.